This thing is a domino-based or Jenga-based conditional logic gate. So right now, before I demonstrate it, I'm going to explain how it works, what the different parts of it are, and how the inputs are keyed in. So, and then also what a conditional is, that's where I'll start. So a conditional is a type of logical operator. A logical operator, essentially, it takes two values, one is either true or false, and the other is either true or false, and then it takes those two values and then returns another true or false value. So, since it's kind of hard to have NOT gates and false and a false value with dominoes with a single chain, because a single chain is either knocked over or not, I'm using a dual chain system. The way this works is if the right side is tipped, it means that those two lines, that set of two lines is a true value. And if the left side is tripped, then it's a false value. So that works for these two sets of two lines, as well as the set of two lines that is outputted at that end. So that's, and of course in here it's not designed so that you can keep track of the two lines. They kind of intermingle inside the mechanism. So specifically a conditional is represented by an arrow symbol. I'm going to say this is A, this set of lines is A, and this set of lines is B. The only time a conditional outputs a false value is when A is true and B is false. In all other situations, it will output a true value. So, the way this machine works specifically, so based on that, there is an AND gate here and an OR gate here. What the AND gate does is it says if this is true, if the right side is tripped and the left side is tripped here, it's false. Then it will output this left side false. And then the OR gate, what that does is if either this is false or this is true, then there's no way that the output should be false. Therefore, it will immediately go to true. So if I tipped this and didn't tip anything else, it would say true, because no matter what I did here, it would never be false. So that's essentially how it works. The specific hardware, this is the AND gate. The way it works is these two blocks will prevent transmission along this line, unless, of course, this is activated, which knocks these out of the way. In the event that this is triggered before this, it'll lean and store energy that way. Then when this removes the barrier, it should proceed through. The reason why there's two blocks here is it's a decelerator, essentially. What that does is if there wasn't a decelerator there, the chain of dominoes would be moving so quickly that it would simply smash its way through the AND gate. It would topple these over. These would not be sufficient to stop it. And of course, if you make these too massive, then even when they're toppled, the signal will not be able to transmit. So I just put the decelerator there. The decelerator specifically for making these AND gates are pretty specific. You have to follow this pattern, otherwise either this won't be able to tip or it will tip too hard. This is the OR gate. It's pretty simple and not really worth explaining. And these are just the crossovers. By the way, the crossovers by themselves do function as a NOT gate because they take the signals and they cross them. So if it's true, then if it's on the right, then it'll switch to the left and so on. So now I should be able to demonstrate it. Looks like this crossover is a little hairy. So I'm going to just tune that for a second. That should do better. If they don't come in at nearly right angles, then they have a tendency to interfere with each other. So what I'm going to do is I'm going to use the AND gate because the OR will always work. There's no subtlety in it. So I'm going to demonstrate the AND side of the circuit. So I'm going to trigger this first. I'm going to say, first of all, B is false. And then nothing will happen on that end. And then when I tell it that A is true, then the AND gate will trigger and it will say that the end result is false. So it worked. So as you see, it has outputted a value on the left side, which means false. So of course, if A is true and B is false, then the output value is false, which is exactly what it said, so it worked as planned.